me share my screen? Can you allow me to share my screen, please?
Yeah, it's coming. Yeah, it's visible now. You can start, Professor Vijay.
So you can see my screen, yeah?
Yes, yes, it's visible.
Right. Good afternoon. Right. It's time here around 5 p.m. Bangkok time. And thanks for inviting me to join the keynote, even though I just know yesterday morning. I try to emphasize on the current research on recycled aggregate concrete that used in Thailand, and also we try and show you what we have done at Walailak University. Okay. So just to let you know that where am I? Walailak University is located at the south part of Thailand there. So the Bangkok is here. So normally we take flight for around 1 hour right here, but if you drive car, it takes about 10 hours. So this place we are regarded as the largest internal area university in Thailand. So this is the front stage of our university. Okay. So I try to just brief about myself. I'm so happy to see some of the panelist speaker and keynote speaker from Sheffield, from Cardiff, that remind me my time back in UK back in 2003 and 2007, and then I just came back and joined academic world after that. So this is my history. I have experience working with the international corporation, which I will show you later on at the last slide. In case if you want to visit us, and we have some exchange program, mobility program as well. So this is my team. So we are really young university, around 30 years old. So in my faculty, we have 3 guys working on the structural side, and also I just have 3 PhD students coming this year from Iran, Ethiopia, and Nepal guys, and we have 2 MSc students as well. So this is the presentation that I delivered during the RCA workshop held in Bangkok back to during 18 to 20 October, and I'm going to show you some highlights from there. So this thanks to this working group that we work together on we are really actively working on the RCA area, and also ranking from the technical staff, and also some laboratory testing program, and also extended to full scale as well. And as you know that this is a picture from one of the Salaburi province in Thailand, as you can see here. And what happened if we want to let our children walking around like this, and again it become like this. So that's why we really want to find some alternative resource to replace the natural concrete. And nowadays it become like this. This is kind of one of the motivation that we are working very hard and try to find the way to work on this research. Sorry, it's in Thai, but this is from the media. Many people, they don't want it, and also create some air pollution, noise, things like that. And as you can see there are many construction waste in Thailand increasing every year. So I think now they probably could go up to 6 billion tons a year. That's a lot. Normally we use this construction waste to fill our land. So there's another way that we can reuse this somehow in the new construction or not. So we know that this is a concrete composition. We have large amount of aggregate and nature, water, cement, and fire aggregate. So we are trying to find a way to replace this the natural resource. As you can see here, we have construction and demolition waste, and also the recycled concrete aggregate. This photo come from my laboratory, so we know exactly the sort come from. So this is really can be regarded with really good quality control. So the industry, they send us the specimen to test, and after we test it, we record what is the complete composite strength, and then we will crush this during our research. So this one is better quality. So in Thailand, before we built the old building, destroyed, and then we fill with in the land. And nowadays we're trying hard to create the code to reuse the recycled aggregate for the new construction. So this is the life cycle, as you can see there. And this is a bit of the history. I joined Walailak in 2019, and then we team up with the previous existing lecturer and try to find the right mix design. And also we apply to the international funding as well. So we got some quite good funding. We got money there. And then we have the international funding for Mitsui, and we also have the fundamental fund project. So ranking really broadly, using the steel fiber, for example, and apply to the rail sleeper this year, and also scheduled diaster plan in column joint subject to static loading. And we also design for the real construction. This one I also published several papers and a case study. Early days, so before I came, so we just do this on one of students crushed manually, and also to have 20 kilograms, you need 8 hours per day. That's why I try to look at in the website, but the concrete crusher machine is really costly, quite expensive there, and also you need to form the board. And this is my motivation. It's like I crusher machine there. So if you can have some jaw crushed together, you can push the concrete or concrete getting concrete, things like that, and then can crush to the various size. That's why. Okay, this is the conceptual design. Some of you may order from the industry ready recycled aggregate, and some of you may think to invent one in your own school or in your own university. So this will be the option, and the cost is very low, and you don't need very highly labor force. So this one I spent like $1,500 to produce it, and local labor can do of conceptual design. I get it last 2 years, and this chart you have to be able to produce 5 to 25 mil the diameter of the aggregate, and also the production rate not less than 1 ton per hour, meaning that you can produce a lot compared to the conventional way. So this is the first prototype that we produced for our research, and it's all fully licensed to Walailak. We got order already in UK, and one in the local university in Thailand to make this. And of course, this one is really low cost compared to the one that abroad, and also can produce up to 3 tons per hour, depending on the size. I will show you very quickly about it. Open play or not. You know what happened? Okay, let me show you.
Dr. Imjai, your voice is not audible. Dr. Imjai? Dr. Inchai, can I interrupt? Dr. Inchai, your voice is not audible. Yeah, that's fine. Now your screen is visible. Yeah, perfect. Now the screen is visible, but still, yeah.
We went outside, so the internet signal is not very good at this time. I'm sorry about that. Can you see my screen now?
Yes. Okay, you can continue.
Yeah. Okay. So this is the example that we use the concrete crusher machine to crush out concrete. So the biggest size is about you can see here, and ranking to medium and very fine one. Okay, and the question arises when if you mix with if you replace with normal concrete up to 25 levels or percent is okay. What happens if we try to push a lot or very high content up to 50 or even 100%? That's why it comes to our research. And also to know that the unit weight and water absorption is much different from the normal aggregate as well, as you can see there. So this is the main area that we're trying to we have been working on using RCA at Walailak and Thailand. So for concrete structure and also FRP seismic and recycle concrete and health monitoring and also the work. So I will show you the one that we're working on the research, the internal design and also strengthening as well. First, let's go to the chair. So the combined use with recycled concrete aggregate with steel fiber. So we try to add the we try to add steel fiber to improve both ductility and also toughness. So this one here, we adding fiber to the beams, and also we try to propose the shear crack induced deformation. If you search my name there and put shear crack induced deformation, you will find the paper. It will have the engineering structure as well. So and the result come really good, and the industry just get our mid design to prevent the punching shear. So we add this one for the sound slab. So we also study the direct shear. So this is a step put off specimen. Yeah, and we compare with the finite element and DAC, digital image correlation, and this come really well with coach math, and we're going to publish this very soon. We also propose some equations, the shear strength equation directly from the concrete alone. Okay, and then we extended to the shear beam, as you can see tested up here. We cast this, and I think this one already published in Building Journal, and we just finished it yesterday. This is for punching shear. So we cast 3 series. The first series is normal concrete. Second series is 100% recycled aggregate, and also we have some opening as well. So the result I did not show you here because it is a preparation and going to publish very soon. But to know that we are working very hard on the shear behavior, and we also propose the modification to the ACI code as well to incorporate the use of RCA. Yeah. In terms of cyclic loading, we have the very good cyclic loading arrangement here. So this is the full-scale case symmetry part of this beam and column. So we turn it over, we apply the cyclic load there, and to see what happens. And after that, we repair and then try to strengthen it with the post-metal strap. And surprisingly, the first crack is decreased, and also the ultimate behavior is better compared to the unstrengthened one. And this is the we run a just to check the strain inside the reinforcement. So this work is ongoing, and one of my PhD students working on it. Not only that, we got the interest from the industry working on the steel structure. They come to us and they want to build what they call the composite beam. So basically, they want to build a precast concrete beam using RCA with different dowel patterns like that. So our work is try to investigate the best performance of different shapes, and we come up, okay, modifying corridor cut is good. And imagine that if this being built for the like 15 or 20, and for the bridge repair, so you can install it directly without stopping the traffic, or even you can install it for the rail work, and you can let the traffic underneath go by. So this one is already published. You can just search my name, and with the steel section, different the dowel pattern. Here there. And we also do the coupon test as well, looking at individual dowel performance. And again, when you show when you see as a result, this one is very good because anchor. We measure the deflection, slip, and also the strain distribution along this region using several strain methods. MCL cut. Also, you can have really minimum weight of the cut part. And this is the test setup, and you can see there the one with the this shape up there. Okay. So we already signed the pattern, and also being work with the industry for the precast unit. This one we built up to 12 or 15 meter range for bridge repair, and it's good for not for install very quickly compared to the conventional way. We also working with the industry again. They come to us and they ask us whether it's possible to use the recycled aggregate for the together with the metal deck. Okay, the guy have really large old buildings, and they demolish them, and then they give us the concrete, the old concrete. So we cut it, and then we put in the metal deck to create the composite section. So this is the test section. We did the ultimate. Well, we did the short-term loading, and we have long-term loading as well. Okay, and also we try to investigate in terms of creep. We leave it for 90 days, and we try to induce like movement in vibration. We have the accelerometer measured here, and it's found that it's good. Also within the acceptable range. And this one is going to be published very soon. So I can say that if you don't use this one for like column joint, if you cut for the slab or even the precast unit, this is okay. Or the RCA level up 50% or 100%. Fire, since we quite small university, we do not have a very large or expensive advanced chamber. So we carried out the 5-pan test. So we generate the temperature at the outside up to 900 degrees Celsius, and we embedded many sensors. So we cut together to interrupt in the event of the real fire. So as you can see here, the sensor go this side, otherwise it will burn out. That's why we know the temperature gradient along the zone. Okay? And then we simulate the temperature distribution along the slab itself, and it found that this temperature here is very it's around 60 when subjected to the fire up to 2 hours. So we leave it 2 hours, and we see the similar ingredient there. Compared with the normal concrete, the RCA can, the temperature reduce very fast, meaning that it's good for the fire resistance compared to the normal concrete. And this is another research that we did. We are trying to replace natural aggregate with the RCA completely 100%, and we built what they call the precast slab for the like animal farm, animal stock like this, and also we put FRP inside. We have the really good corrosion resistance, and compared with the conventional one, which is pre-stress, and we are okay. It works really well. We design with the 400 kilogram per square meter. For example, this one it's okay, and then it's already sell in the market there. And this is different research aggregate concrete product that we produce from Walailak together with the industry. We have the ready mix with the bitumen like that, and we have maybe with insulated. This is foot massage pad made from RCA and the old use of the tennis ball. So it's good, very good. I got one as well under my chair. Okay, and we have the slab 4 like this. We have the concrete cutter machine like this. They're on the market as well. And this is the road curve, different shape. And right now, I am working on the micropile. So the micropile work use 100% of RCA, and the reinforcement inside here we use the FRP. So this one is under investigated, and also hopefully we can come up with a new product. So this is the whole picture that we work on RCA. Okay, it's just some part of my research project right now at Walailak University. And for some of you might be interested to visit us, we have many international mobility and programs. So you may try to go to the Center of International Affairs. They have student staff mobility. We offer you free accommodation and also free ticket to visit us, like 1 week, things like that. So we have many professors visit us already, and I also share of this event. So some of you might be interested in next year. So this is about the structure on FRP itself, composite structure. And today I'm quite busy, but I try to off my time here. We have international program. We got UNIVERSI from Malaysia, which is now. And planning for the really active RCA groups and working groups, and we keep we share knowledge. And I'm not sure some of you here or not, but we're trying to our best to exhibit the RCA Excellence Center in Thailand very soon. Okay, last but not least, this is the Walailak land of glory. I'm really welcome you to visit me, and if anyone of you want to come, just send me an email. Okay, thank you.
Thank you, Dr. MJ. That was a wonderful talk on recycled aggregates, especially how the specialty of this talk is you have mentioned the application for large scale. So you have shown the earthquake related application, and finally the RAC products. That was really awesome. So there are some questions from the participants. So I will read out the questions one by one, and you may answer to that. Okay, so the first question is from Amina Dekak. She has asked about, since pH value of aggregate due to carbonation of recycled concrete can be lower, did you investigate corrosion of steel concrete composite sections?
Trying to read because I cannot hear you very well.